supposed to already have completed, so let's run through the steps real quickly. The first thing you need to do is factor. So we have a GCF of 2. We'll pull that out, and that results in that trinomial, which gives us x minus 6 and x plus 2. In order to find our x-intercepts, we're going to set each piece of that equal to 0. Technically, we would set the greatest common factor equal to 0 too, but since it doesn't have a variable, it is not going to give us an x-intercept. This would give us 6, 0 and negative 2, 0. Once we factor those, we will be able to find our axis of symmetry. So we'll put our negative 2 on here and our positive 6. The midpoint is our axis of symmetry, so the midpoint falls at a positive 2, which gives us x equals 2. We write the equation for vertical lines as x equals. Make sure that that is an equation. That also gives us the x-coordinate of the vertex to be a 2, which we plug in over here. When we plug that in, the one thing that we will want to make sure that we haven't had to worry about in previous problems is that we follow order of operation. The 2 gets squared before it multiplies, so that results in 2 times 4, which when we follow through here then, that gives us a negative 32. That is the y-coordinate for our vertex. Obviously, negative 32 is not going to fit very well on our graph. We're just going to come way below the graph and put a 2, negative 32 down here so that we have that point sort of marked. Next thing we can find is our y-intercept. The y-intercept, you can always plug 0 in for the x, but since this is a standard equation, that means when I plug 0 in for the x's, the c value will be our outcome. So that is going to be 0, negative 24. Also, that doesn't fit very well on the graph, so we'll just kind of put that 0, negative 24. And then we want to find its corresponding point, symmetric point. It's 2 away from the axis of symmetry, so we'll continue 2 more. That'll give us 4, negative 24. At that point, we have 5 points now, and we can get a graph. We also know by appearance that this has a minimum. We could also tell that because the x squared is positive and there's no reflection over the x-axis. Example 2 you were supposed to already have done as well. We've named transformations before in the past. We know this goes right 3. It has a vertical stretch of 2, and then it will go down 2. Right? Knowing your transformations, you can take that parent function, y equals x squared, and transform it. The vertex will simply move right 3 and down 2, and from there, my parent function should go right 1 and up 1, which is 1 squared, and then right 2 and up 4, but because of the stretch, those up values will actually double. So we'll go right 1 and up 2 instead of 1. We'll also do that symmetrically, so we'll go left 1 and up 2. And then we'll go right 2, and as I said, we should go up 4, so we will go up 8. And left 2 and up 8. At that point, we've got our parabola, just nice 5 points. We do want to make sure we draw our axis of symmetry through the vertex. Naming those pieces and parts, the vertex was at 3, negative 2, because we went right 3 and down 2. It does have a minimum. I can tell because there's no reflection over the x. I can tell from the graph. I know the axis of symmetry will be x equals 3. Range and domain. Domain for any parabola opening up or down is going to be all reals. Either way you want to write that. The range starts at a negative 2 and goes up infinitely. So it would look like that, or you could say y is greater than or equal to negative 2. All right, looking at example 3, this is a repeat of number 1. So all we're going to do is change it to vertex form. this is different than what we've done in the past, so please pay attention. We have not had a coefficient with our x squared in the past. We do have to factor, but we only factor away from the x values. That 24 does not get involved. So we'll pull the 2, factor that 2 out, leaves us x squared minus 4x. We're going to go ahead and put a blank so that we can complete the perfect square trinomial. Then we'll bring our minus 24 down, and since we added, we will subtract that blank. And here's the piece you've got to watch out for. Notice that blank is being multiplied by 2. So our blank here has to also multiply by 2. Now we just need to decide what goes in the blank. It's just like before, the 2 does not affect that. We look at the x value, half of it, and square it. Half of 4 is 2, 2 squared is 4. Goes in both blanks. Then we simply factor from there, so that gives us x minus 2 quantity squared. You can do that as trial and error if you need to. Do your arithmetic out here. That's a negative 24 minus 8 now, so that is a negative 32. Hopefully this equation looks familiar. We know we've got a vertex of 2, negative 32. Vertical stretch looks like example number 1. If you look at number 4, it is a repeat of number 2, but this time they want us to expand it and put it in standard form. Just like what we've done before, we'll have to square this binomial, but there is going to be a number out there waiting to multiply as well. Remember your order of operations though. We square first. So in my mind, I write 2 of them and I've squared it. I haven't done the multiplication yet, but that's okay. That takes care of the square. Now I just need to multiply. My preferred method is I'm going to distribute the binomials. I'm going to get the x squared minus 3x plus 9. Then I'll just bring down that minus 2 and 2 times. Then we multiply before we subtract, so we'll distribute the 2. You could go ahead and combine your like terms if you like here. So that's a 2x squared minus 12x plus 18 and minus 2. So your standard form should say 2x squared minus 12x plus 16. And if you notice from example 2, we did have a y-intercept at 16. It was a vertical stretch of 2. That should look a lot like what we did on 2. Going on, we're going to skip to example 9. And on this one, you've got a negative 2x squared and a negative x there. You can't quite see it on my board. Can over there. The first thing, we're going through these same steps. They tell us to factor first. We factor to find x-intercepts. I am going to pull the negative 2 out, so that's x squared. Watch your signs. That'll turn into a positive 4x. And we will go ahead and include the 10 now because we're not completing the square. We're not changing it. We're just factoring. So that'll be a minus 5. Then you're simply going to factor that trinomial. So that's x plus 5, x minus 1, and our x-intercepts are going to be at negative 5, 0, and 1, 0. We graph those so that we can find the middle, which is our axis of symmetry. All right, and the middle of that would be negative 2. All right, so I know my axis of symmetry is x equals negative 2. Vertex has a negative 2 for the x-coordinate. Looking at the standard form, this being negative tells me that it's actually going to be a maximum this time, which means it will open down. Vertex then should be up between those x-intercepts. To find its y value, I'm simply going to plug the negative 2 in. So that's negative 2 times negative 2 squared. This time you do need to be very careful with that order of operations. You are going to square the negative 2 first. So negative 2 squared is a positive 4. that positive 4 multiplies times the negative 2 to give you a negative 8. Bring your 16, positive 16 plus 10 down, so that is an 18. Which means it's going to be off of our graph. But that's okay, it's just going to be up above slightly. And we'll label that negative 2, 18. Right, we could find our y-intercept. That is asked of us, so we might as well do that. We do have standard form, so we know that the y-intercept is this c value. So I get 0, 10, which means it's going to be here, and I'll have a symmetric point that's 2 away, so it'll be 2 this way at negative 4, 10, and I can draw my parabola. Not a very pretty one, but it's okay. We've answered all the questions, so let's go on to number 10. This one is in vertex form, so we're naming transformations. We are going to go right 5, reflect over the x, have a vertical stretch of 3, and then go up 3. The vertical stretch, the reflection tells me that I'm going to have a maximum because of that reflection, and so that helps me get an idea of what this is going to look like. I'm going to move my vertex, the 0, 0 point, right 5, up 3. There's that. And from there, it should turn down. Parent function normally would go to the right one and up 1. Mine is going to go down, since it reflects, and not 1, but 3. So on both the left side of my vertex and the right side of my vertex, I will come down 3. To go another step with that, I could find the y-intercept, but since it's in vertex form, it's easier to go ahead and just go 2 to either side. Normally I would go up 4, but I'm actually going to go down 12 this time. So I will be something like that. That will be at, is that 5, 6, 7, negative 9, and 3, negative 9. And that should look like that. Axis of symmetry falls through the vertex at x equals 5, and our vertex was 5, 3. And last but not least, domain. Domain is always going to be all real, and the range is going down this time, so it's negative infinity up to 3. Looks like that, right? We're going to go on and look at 15. On 15, it is transformation. We are going to go left 3, have a vertical stretch of 2, no reflection, and go up 4. When I go graph that, that will be left 3, up 4. We're here. Flip, don't flip down because there's no reflection. We'll go 1 to the right, and instead of 1, we'll go 2 up. Also do that on the left. We'll go 2 to the right, and we'll go up not 4, but 8. So you're going to have something that looks like this. Right? Vertex is going to be at negative 3, 4. This one, because it opens up, is still going to have a minimum. X equals that x value of negative 3. The range, well, domain, all real, and your range is from 4 to infinity. Right? And the last question, we'll pick up on this tomorrow, but what is it you notice about our x-intercepts? All right.